What's up, geometry? Thanks for tuning in with another episode of Math with Mullins. Today what we're going to talk about is your quiz review for lessons 2.4 through 2.6. So hopefully you've had a chance to try these questions. Let's go ahead and get going. The first proof we're looking at is PR is congruent to QS is our given. And what we want to figure out is how could PQ be equivalent to RS? Let's go ahead and talk about it. Our reason for letter A is the given, because that was what our given statement was. Then it says PR is equal to QS. This would be the definition of congruent segments. When we have PQ plus QR is equal to PR, that is the segment addition postulate. And you'll notice you're going to have another one right below that, and that's okay. The other segment addition postulate you could be QR plus RS is equal to QS. Okay, now that we have that, we know that PQ plus QR is equal to QR plus QS. That would be either the substitution property or the transitive property. Just because you are stating that both of these are equivalent to one another using that middleman. Then for the subtraction property, we are subtracting QR from both sides so that PQ is equal to RS. So the definition of congruent segment should look like this. PQ, line segment, is congruent signal to line segment RS. Okay. Next up, we have given AB is perpendicular to BC and angles 1 and 3 are complementary, prove that 2 and 3 are congruent. So the first thing we're going to do is state our given, which is segment AB is perpendicular to segment BC. Then it says the definition of perpendicular. Well, when we're looking at AB and BC, that means angle ABC is a right angle. Okay, and that letter C is already filled out for us then. The measurement of angle ABC is equal to 90 degrees. Definition of right angle. Cool. Now let's look at this next part. The measurement of ABC is equal to the measurement of angle 1 plus the measurement of angle 2. That is your angle addition postulate. Okay. Now we can substitute 90 degrees because we know it's a right angle is equal to the measurement of angle 1 plus the measure of angle 2. So if you're trying to prove that angle 1 and angle 2 are complementary, that's the definition of complementary angles. Okay, so when we're coming back to our given, angle 1 and angle 3 are complementary. So that means the measurement of angle 2 is congruent to the measure of angle 3. That would be your substitution. Okay. We have another example right next to it. It says given angle 1 and angle 2 are a linear pair, the measurement of angle 1 plus the measure of angle 3 should be equal to 180. We want to prove that angle 2 is congruent to angle 3. So our given is angle 1 and angle 2 form a linear pair, and the measurement of angle 1 plus the measurement of angle 3 is equal to 180. When we're trying to use the supplemental theorem, we can say that angle 1 is supplementary to angle 2, so that when angle 1 is supplementary to angle 3, that is the definition of supplementary angles. Okay, so when we're using the angles that are supplementary to the same angle are congruent, we can say that angle 2 is congruent to angle 3. Okay. Number 4, given the measurement angle A and measurement angle B is equal to 90 degrees, angle A is congruent to angle C. We want to prove that angle C plus angle B is equal to 90 degrees. We already have a few of these filled in, so we're just filling in the blanks here. Our givens are measure angle A, measure of angle B is equal to 90 degrees. That means A and C could also be the same congruency. So if the measurement of angle A is equal to the measurement of angle C, then that is the definition of congruent angles. Because we know that, then if we substitute angle C with angle B, we substitute angle A with angle B, we can then say that the measurement of angle C plus the measure of angle B is equal to 90 degrees. Because A and C are equivalent, we're just substituting the A with the C. Flipping over on the back, we have another given proof, and we're just going to fill these in. So our statement BC is given equals to DE. The segment addition postulate would just mean AB plus BC is equal to AC, so that when we are substituting it, proving that AB plus DE is equal to AC, that would be our reasoning for this one. Okay. Number 2, given Q is between P and R is between Q and S, PR is equivalent to QS, so prove that PQ is equal to RS. So our given is Q is between P and R, and the next piece says PQ plus QR is equal to PR. That is the segment addition postulate. Okay. Next, letter C, R is between Q and S. Well, that's another given. So the other segment addition postulate we can say is QR plus RS is equal to QS. Okay. Going from there, PR is equal to QS. Well, that is our substitution right here. So that PQ plus QR is equal to QR plus RS. We can use the, I messed that up. This substitution part should have been letter F, because letter E is our given. And this one is our substitution. So that when we find this down here, we are showing the subtraction property. So when we finally write it out, after subtracting everything, PQ is equal to RS. Okay. Last little bit on the back. We have FD bisecting EFC and FC bisects angle DFB. So we're given those two items. So to go on with section 2 of our reasoning, that's the definition of the bisector. So the definition of congruency just means EFD is congruent to angle DFC, and DFC is congruent to CFB. Okay. Now we would use the transitive property of congruency for that same reason. So EFD is now congruent to CFB because of the definition of congruent angles or congruency. Okay. Number 5 says, given angle 1 and angle 2 form a straight angle, prove that the measure of angle 1 plus the measure of angle 2 is equal to 180. The first two are given to us and our reasoning, but now we need the angle addition postulate. Well, the angle addition postulate can state that angle 1 plus angle 2 is equal to the measurement of angle ABC. So when we want to substitute steps 2 and 3, that means the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. Last little bit. Number 10, given WXY is a right angle and angle 1 is equal to angle 3, prove that the measure of angle 2 plus the measure of angle 1 is equal to 90 degrees. Well, we know that WXY is a right angle, and since WXY is equal to 90 degrees, that's the definition of a right angle. So the measurement of angle 2 plus the measurement of angle 3 is the angle addition postulate. Sorry for the bell. So when we substitute that, WXY should also be equal to 90 degrees. So that means if angle 1 is congruent to angle 3, the measurement of angle 1 is equal to the measurement of angle 3. That's the definition of congruency. So that the measure of angle 2 plus the measure of angle 1 is equal to 90 degrees. And that is substituting steps 4 and 6. Okay. That is going to be all I'm going to ask you to do for your quiz review. You still have extra examples, and I will share those with you in class if you wanted to try those for extra steps. But for the most part, that first page is going to cover us for that quiz tomorrow. Thanks so much for tuning in, and we'll catch you next time.